Well, good morning, everyone. I guess depending where you're at, but good morning from Minnesota. It's Todd Mansell here with Caterpillar, and welcome to today's webinar on paver technologies to solve segregation and smoothness issues. So I'll be kicking off today with the presentation, and I've got some co-presenters that will be joining in after I do the opening part here. We'll have Henry from BoMag has a little bit to contribute here, and then Nars will be following up after Henry. So we've got paver technologies to solve segregation and smoothness issues, and I believe we will maybe have questions through the chat. I'm not 100% sure on that. And we should have some time for Q&A at the end of the session. So again, welcome. And with that, I will jump into the kickoff our webinar here this morning. So we talk about solving segregation and smoothness issues. So quickly to start off, let's just kind of define those topics. One thing we've got is what we call material segregation. So when we talk about that, we're talking about the aggregate as it relates to paving and hot mix in today's session. And as you can see on the slide there, the basic thing here with material segregation is handling of the aggregates or the hot mix once it's produced at the plant. So generally, again, large rocks want to roll to the outside of piles and all that sort of thing. So we'll talk a little bit about material segregation, and then you'll get a lot more today on thermal segregation. And we look at that, and this is probably the most famous picture ever taken of a thermal image from Washington State, but just showing a thermal image behind two pavers here and showing some temperature differentials. I got to get on my little soapbox. I like the term differential better than segregation, just because we're talking temperature here. So we've got material segregation, thermal segregation, and with that, we will jump into some of the technologies that help us solve those problems when it comes to construction in the field. So real quick, I'm going to kick off today with paver-mounted thermal profiling. So sometimes you've heard as a technology that's available. So there's several manufacturers out there now that have this technology, mostly pretty recent to the market, with the exception of MOBA. They've been the industry leader on that for many years now, but some other manufacturers have jumped in as EMPT has gotten more popular. So I'm just going to give a quick overview on the specs on the CAP machine, and they're generally a little different, but overall pretty similar for all the manufacturers. So I'm not going to go through the spec sheet here, but plus or minus 2 degrees Celsius on the camera accuracy. Generally, when you look at these thermal profiling systems, they're set up on the paver. It's a thermal imaging camera or infrared technology that's reading the mat temperature behind the paver as we're paving. So there's a setup procedure for that. You're setting the scanning width, so depending on the mat width that you're paving. And then another thing that we've, and we'll talk a little bit about the analysis software and data later on, but there's some things in there when we get to looking at this thermal data that we have to take into consideration, such as the edges of the pavement and the longitudinal joint area where it's typically cooler. So another thing, again, depending on the manufacturer, but you'll have some sort of display on the paver itself showing the thermal map as we're paving down the road. So we've got temperature on there. This example, you can see the delta or the change in temperature across the mat as we're paving. Different reporting involved. So again, this example is just showing a what we call an in-field report. So it's just a summary of some of the thermal data as we're going along here. And the big thing here is not only the thermal imaging data, but the location data that's associated with it. So again, just on the CAT system to be, but again, all the manufacturers have data files that are exportable or import to the Beta software. Again, we'll talk about that a little bit more later. NARS has some more to talk about that. And if you want that Beta software, intelligentconstruction.com is the website where you can go and it's a free download. So that's your analysis tool, if you will, that takes all the manufacturer's information. Doesn't matter what brand it is. We're able to import that data and analyze it in the Beta software. So there's also, as many of you know, the intelligent compaction data is also in the Beta, or able to be analyzed in the Beta software. So why paver-mounted thermal profiling? Segregation in hot mix causes premature pavement distress. Nothing new there, right? Thermal profiling has been found relatable to hot mix segregation. Thermal profiling has also been some studies showing a correlation with in-place density. So that's one thing. There are a few things for us to look at. We generally know that less temperature differential results in more uniform compaction in the field and improved smoothness because of even as it relates to the compaction part of things. Another nice thing from a contractor's perspective on the thermal imaging, and again, we'll see that more as I go through a few slides and illustrate that, is improved consistency on percent within limit specifications. And again, it kind of relates back to the uniformity of temperature that relates to more uniform compaction in the field. So another nice thing, maps the entire paved surface. So what I personally really like about it, it's real-time information that the crew can make changes and see results during paving. So we can tweak things, we can change things in the field as we're paving to improve our thermal profile or improve the uniformity of temperature of the mat, again, as we're paving. Not something we look at after the fact and scratch our heads and wonder if do we have any notes on why we've got a failure in this particular area and things like that. Some other benefits, it's a great indicator, again, uniformity of compaction, uniform aggregate gradation and or material segregation. So whether that's loading from the plant, hauling, trucking, dumping, transfer to the paver. It's a big indicator on equipment maintenance and setup or operational best practices. So when we see different thermal patterns behind the paver, we can identify those and kind of trace them back to, hey, have we got an equipment problem or maintenance thing we need to look at, or is it an operational thing that maybe we're not doing some of the best practices for example, head of material and managing our mix level in the hopper. You can see things like plant production, temperature variability, even moisture, other sudden changes in mix properties. So that goes to handling aggregates at the plant and feeding the aggregates into the hot plant. If we get into areas of different moisture contents, that can show up on the thermal image in the form of temperature variations. And again, some other best practices there. Another big thing I like is the fact that you can see paver stops. So location and number of stops and duration of stops. So a lot of benefits, a few things to consider when we look at paver thermal data. You know, the big question, how much temperature differential is too much? I don't think there's a single answer for that, but there's definitely lots of discussion around it. And there's been some research on that. Exceptions. So it's one thing to look at the data, you know, on my screen if I'm in the office, and there's a lot of things I can identify on that, but there's always certain things that really need to be correlated with what actually happened or was going on in the field at the time. I guess my big point there is just be cautious when we look at the data, that we don't jump to conclusions about what might be happening out in the field. Surface temperature, again, it's going to be a little different than the internal mat temp, which I don't think is a big deal. It's no different than what we do nowadays using an infrared temp gun. Just be aware that surface temp is not quite the same as the internal mat temperature. Edges, longitudinal joints, talked about that. When we look at the data, automatic grade control sensors, ski placement, those are things that we just need to consider. And we've been having discussions about that as well. It gets picked up by the thermal camera if you've got the ski over top of the new mat or within the camera's range. So those are just little things that we need to be aware of. So segregation and smoothness, we can identify physical segregation by looking at thermal images. It helps in identifying the equipment deficiencies that lead to physical and thermal segregation. In terms of smoothness, temperature differentials, again, compaction, basically lead to compaction differentials. So there's nothing new there. Operational techniques and tracking paver stop. So it's really a great tool to identify things we already know, but now we're measuring it, we're tracking it, we know locations, and we can act in real time to correct some of these things. So now I'm going to jump into talking about some more detail on the high level stuff that I just talked about. So paver stops is one of them. So again, we're talking about segregation and technology. So the technology is the paver-mounted thermal profiling, can track paver stops, so length and duration. What happens when we stop the paver? The screed settles, right? So long stops, a lot of times if it's more than 5-6 minutes, those bumps are not coming out with the roller. But one of the new technologies that we have on pavers out there nowadays is what we call a screed lock or screed hold. Different manufacturers have different names for it, but when the paver does stop, it locks that screed so that it won't settle into the mat. So that's a technology on the equipment itself that is that we can track, see where those stops are with the paver-mounted profiling, but equipment thing to help correct that. Also, when we get paver stops, what else do we get? We get variability in temperature right behind the screed, underneath the screed in the auger chamber. So that's all this slide's showing. If you've got mix in the auger chamber, you've got mix under the screed plate, you've got mix under the catwalk behind the screed where the rollers can't get up to if that paver is sitting there for a while. And then you've got all the mix behind that you've already paved where the rollers can get on that. But again, this is just showing stuff that we can pick up on the thermal imaging, but also have technology on there that screed lock, screed hold, but that's still not going to get rid of this type of thing that we're seeing. If it's a long stop, paver takes off again, got temperature differentials, those are going to translate into potentially low density areas and almost definitely still some smoothness problems. Centerline streak, so that's something we see a lot on the road. It's usually something we can correct with a little investigation. There's a couple main causes are buildup on the deflector plate. So I'll show an image, a couple slides of that. Those deflector plates can be worn out. And the other big thing on that center line quite often are what we call the reversing augers that are designed to run mix under the gearbox on the paver or the chain case and get mix underneath that what we call a dead area where the mix typically isn't moving. So if those reversing augers aren't installed correctly, which does happen a lot, if you've ever looked at them, they're kind of tricky to know which way to install them so that they move the mix in the right direction. So, but you look at this image on the left here, you can see visually, if you look toward the top, the mat, there's nothing there, right? It looks beautiful. But you look at the thermal image inset there on the map, and you can see that center line stripe. Again, what's the paver, the thermal profile, this is showing up. So if I'm on the paver, of course, we don't want that inconsistency in our mat, temperature-wise. Could be a weak point in our compaction and an early distress or cracking or failure point. So it tells me as a paving crew, maybe I need to look at my augers, I need to look at that deflector plate and make sure those things are in good shape. So there's the deflector plate. It's kind of hard to see there. It's got mix buildup on it, so that mix is coming back from the right side off the conveyors from the paver hopper to those augers, and that deflector plate is just kind of a triangular piece of metal, and it does need to be cleaned and even replaced every so often because it is just steel, and with constant mix flowing over it, they wear out and don't do their job. But the whole idea of that deflector plate, again, is one of the, not a new technology, but on existing paving machines to help minimize or even eliminate that material segregation and thermal segregation on the center line. So you got to make sure that, number one, it's there, it's clean. So sometimes you got to knock that material off of there with a shovel handle or something, maybe every half an hour or during paving, just depends. But if you see that stripe showing up on your thermal, there's a good place to look. And the other thing here is just on the left side, you're seeing what we call a reversing auger. So again, all that little quarter segment or 6-inch auger piece that there is doing in this picture, and there's different ways you can set them up, is moving that mix underneath that chain case that drives the augers to keep mix moving underneath there. So the next slide here, I don't know if you can hear me or not. So if you're able to see that there, that you could see that stagnant mix kind of just sitting there. And again, that's built up on that deflector plate area. So that's something you just, again, got to look at, knock that material down. And once the reversing augers, or we knock that material off of there, you see in the thermal image, that center line stripe pretty much goes away. Head of material, so switching gears, another thing we look at thermal, so you'll see head of material has a huge effect on the quality of our paving. I think I would argue 85 to 90% of our paving problems in the field are related to managing this head of material. And I know Nars will talk about this a little more in his presentation, but managing the hopper level, and this image is just showing different temperatures in the hopper itself, especially when we run that hopper low. And those cold areas, hot areas in that hopper are going to show up in the mat behind the paver if we don't manage that material in the hopper, and the hopper holding the wings and all that properly. So conveyor ratio dials are another technology on the pavers that they've been around for a while now, but basically replace what used to be constant speed conveyors, bringing the mix from the hopper back to the augers. So with the ratio dials on the newer machines, they're a ratio of the conveyor speed to the auger speed. And the big thing here is now our conveyors are variable speed. So as opposed to the old days where it was a fixed conveyor speed, we're able to adjust conveyor speed based on our production to manage that head of material, again, back in the auger chamber. So again, just keep in mind, and again, Nars will talk a little more on the free-floating screed and all that, but when that head of material varies or changes, that's when that screed wants to either take a dive or go up or drop down and change our mat thickness. So head of material ratio dials are a big deal. But again, this stuff will even show up on a thermal image if they're not set up right, and you'll see changes in that temperature. So half auger height is really our goal for minimizing segregation and having a constant head of material, constant thickness. And this image here is just showing, again, so talking about conveyor ratio dials and auger speed. Again, some of this stuff, and as a paving contractor, over time you'll see this stuff and be able and start relating it to the operation of the paver itself. What's going on? Am I taking off and my feed system's kicking in? My feed sensors aren't maybe aimed exactly where they should be. So my augers are kicking on fast and then slowing down, or are they taking off fast or slow and then speeding up? So there's different patterns. We could go on for ages to showing that type of stuff. But again, this is the power in it to me for improving quality and minimizing both mix segregation and improving our smoothness. And this picture is just showing, you know, if you get feed sensors are not aimed properly, you get on and off auger movement. Again, something you can identify in that thermal image. So it's very, very powerful tool, quality tool to have on your machine. So that, I apologize if you can't hear me over the audio here. So with those last,
we could hear you, Todd.
Pardon me, Nars?
We could hear you.
Okay, was I drowning out by the?
No, the video was drowning out, but you're doing good.
Okay, thank you. Yeah. So those two video clips just showing fast auger speed and now showing on here that 20 to 40 RPMs or about 2 seconds per revolution. So again, it's just a goal, but paver-mounted thermal profile, see different patterns. We can go back, look at our auger speed. If we got wispy images behind the paver, it might indicate on-off auger movement or just high auger speed, slow auger speed, which those things translate to material segregation and thermal segregation. Auger extensions and tunnels, again, not a new technology, but they are a design feature, if you will, that are on paving, all pavers. The nice thing when I say recent years, maybe 10 years, but the nice thing nowadays is we have hydraulically extendable ones, so people tend to use them more because they're easier to use. But the big thing here is we will see different patterns again in thermal and mix segregation behind the paver if we're not using the proper auger extensions and tunnels. So image here just showing wider width paving. So when we do that, we want to make sure that we have auger extensions to get that mix all the way out to the end gates. And rule of thumb, or the golden rule, is always have auger or mainframe or tunnels in front of the augers to prevent that mix from rolling forward and segregating. That slide is just showing the difference between a front and rear mount screed, and it'll make more sense when I get to the next slide. But if you look at the main screed that's attached to the paver in the direction of paving, so on the left side, you've got what we call a front mount screed, and all that means when we say front or rear mount is the relationship of the extensions that go in and out to the main fixed screed. So on a front mount, the extenders are in front of that main screed. On a rear mount screed, the extenders are behind the main screed. So why did I say that? When it comes to auger extensions and tunnels, a little less forgiveness, if you will, with the front mount screed because of the way that mix flows. So we've got to have auger extensions that are generally at the most about 1.5 feet from the end gate on a front mount screed. With the rear mount, because that mix flows back and it flows back into those extenders that are behind the main screed, a little more forgiveness, if you will, in terms of auger extension and tunnel extension. So, but regardless, we always want to have tunnel extension, whether it's hydraulic and then bolt on to get it out even further in front of those augers. So we don't want to see what we've got on the right side of the screen there. So this video here just showing, look at the head of material or the amount of material they're carrying there, just because they really don't have enough auger extension. A little hard to see here, but you can see the segregation in the mat behind. So you see that segregation in the mat without those augers and tunnel extensions. So again, that'll show up on a thermal image as well. So if I'm looking at an image, it says, hey, I better look at this and see if that's my problem. Adjustable height augers, so another, again, design feature, if you will, that are on all pavers. And there was a time when these were just fixed height, but they're hydraulically adjustable up and down. Again, help prevent segregation, help manage that head of material that we just saw in the last video clip that was way overloaded. So if we get those augers in a good position, we typically recommend about 2 inches above the mat surface that we're paving. And that's a good starting point. We might have to tweak it, auger height up or down as we're paving to improve that mat texture and manage that head of material. But again, I've seen augers running, really high, way too high, and you've got a big head of material back there causing problems with that screed going up and down and increasing and decreasing mat thickness and affecting our smoothness. And auger height. So again, even on a thermal image, you can tweak the auger height and see a difference in what the thermal looks like behind your screed. You'll see a difference in mat texture, and it will show up on that thermal image. Mixed delivery and handling. So different thermal patterns again. The slide here, courtesy of MnDOT. Thanks, Rebecca and Greg. I'm not sure exactly where this came from, but showing the different things, thermal pattern here on end of truckload, for example. So again, big powerful tool giving us something when we see that data, what can we do differently operationally to improve that thermal profile? Because again, more thermal or more uniform thermals, more uniform compaction, better smoothness. So just in that example, end dumping. So I mean, generally we're looking at end dumping. It's an operational thing in this case, right? So if we look at the slide again, I'll back up here. We can see end of truckload, differences in temperature there. So that tells me as a paving crew, are we following a good end dumping procedure? Pave at normal speed, pull the hopper wings if we can without spilling mix on the grade. Not running the hopper too low, stopping, letting the next truck dump on top, and then continue on again. So it really just goes again to identifying, in this case, some best practice that we could maybe be doing better in the field to get rid of that or minimize that thermal segregation that we saw. Even goes back to the plant, right? We're always going to get some crust on the truck if we're hauling the mix from the plant to the job site. Maybe, again, depending on what we're seeing in our thermal image and the mix type we're using and the time of year, temperatures, all that stuff. Maybe I'm looking at how we're loading trucks. Maybe a remixing device would help. And Henry's going to talk about that a little later here. So lots of data. Material transfer vehicles. So again, not really a new technology by any means. They've been around for a long time, but we are seeing them used more nowadays because we're looking more at thermal and material segregation and uniformity for both ride and compaction. The big things with the transfer vehicles, and in this picture, at least, this is a non-contact with the paver. So we're paving along, there's no contact with that paver, and it's continuous paving. So between truckloads in this picture again, truck is end dumping into the head on that transfer vehicle, and the transfer vehicles moving that mix back into the paver hopper. So we'll look at a few things there quickly, and I know NARS has some more on this, but so we got the hopper insert that transfer vehicle is dumping into, and there's a lot that goes into the design of those inserts. So there's different designs, baffles in there, things like that. So again, if we've got thermal imaging technology, we can look at that. Maybe we try a different hopper insert or a different design on it. And a lot of contractors weld up their own designs, put their own baffles and different things inside these hopper inserts, or even make their own hopper inserts. So again, just great information being provided by the thermal to allow me to make improvements in my operation. And it's going to track operation things such as best practices, right? Again, large aggregates, when we get the material segregation, roll to the outside edges, doesn't matter what we're handling it, whether it's in a hopper insert or in a truck or in a silo. Mix always wants to segregate, and the big rock roll to the outside edges. So again, could identify just some best practices that we could be doing better, like not running the hopper insert too low, for example. And that picture is just showing a low level hopper insert. So again, something we got to be careful of, right? Having a hopper insert or even having a transfer vehicle does not solve segregation or smoothness problems if we don't operate them correctly. Spills on the grade. So again, and I keep relating this back to the thermal because, again, I just think it's such an awesome tool for showing, pointing out areas that we can, in the field, we can work on real time and make improvements, not after the fact or after the pavement fails. So spills on the grade, we've all seen this. If that happens, and it's thin, we pave over it visually on the surface. Usually you don't see anything. The mat looks perfect. Roller operator might feel that. Good chance that he or she will feel that when they roll over it. But when we roll over mix like that gets spilled on the grade, it never gets fully compacted. So I always like to call that the worth of a pothole. That's likely where it's going to show up in those areas. Thermal image, and this is an old image, but again, showing a spill on the grade, and it shows up in the thermal. And visually, looking at the mat, we would never see that. Another, again, I'll call them design features, not necessarily technologies in my terminology, but low entry hoppers. So when we talk about spilling material on the grade, that's one thing that's an optional design feature. Again, mainly useful when we're doing end dumping. And basically that just allows a better fit for the truck into the hopper, depending on the trucks you're using, to minimize spilling material on the grade. And folding the hopper apron. So that's just an operational best practice again. If we are folding the wings, and I always get people saying, can we fold the wings? Yes, no, good, bad. If you do it properly, it's not a problem. I would almost argue in a lot of cases it's better to do that, but do it well. Make sure the flashing on the paver is working properly and not all beat up and mix is spilling in front of the paver. If you do it well, generally you can put down a good uniform mat. We do run into problems when we get into the larger sized mixes. So get into the 3/4 inch, 1 inch mix, then I'm more on the recommendation of don't fold the hopper wings. And this technology is just folding hopper apron. So you can see at the right side there, that folds up when you fold those wings to minimize, again, or eliminate that spilling of material on the grade in front of the paver. And push rollers. So pavers have the push rollers on the front that are in contact with the truck when we're end dumping. And again, it's a design feature. They are adjustable. So if the truck isn't fitting properly into that hopper, or able to back up far enough into that hopper, those push rollers are adjustable on the paver to, again, minimize or eliminate that spilling on the grade. Just a quick note on windrow paving, because again, nice image on the right there, courtesy of MnDOT, from a pickup machine, a job where there was a pickup machine. But the big thing here, and again, it'll show up on thermal, is when it comes to windrow paving, is trying to make sure that we operationally we back up over the windrows and keep a continuous windrow going. Generally, gaps will show up in the windrows, will show up in the thermal, also affects our head of material, particularly if we're using just a windrow elevator as opposed to a remixing transfer vehicle. So just something operationally. Just it might tell us, looking at our thermal image, it might say, hey, we need to adjust our pickup head on our pickup machine or our transfer vehicle. Again, if we're doing windrow paving, because what happens, again, if that material is not picked up clean off the grade, that picture on the left there is material that the scraper wasn't adjusted properly or as well as it could have been to pick up material, or that mix or windrow. On the right side, I actually took that core right out of that same spot that you're looking at on the left after it was compacted. And that's what you get on that interface between the new material and the existing material when we have mix spilled on the grade. So that's definitely a quality issue. Water will get in there at some point, and that'll want to debond or separate and end up failing prematurely. Some other technologies here: 2D, 3D grade control. So again, these are really going to help with smoothness. They're going to help with joint matching when we're paving adjacent lanes. NARS is going to talk more on the 3D part, but one thing I would like to emphasize, and I think we're on the same page on this, is 3D is great technology, but it's not for every job. And the design file is really the critical thing, in my opinion, on when you get to 3D paving. If the design file that's loaded on the machine to control the screed elevation and slope is not correct or not accurate or not lined up correctly at the starting point, with 3D paving, we can run into a lot of problems. But if we have a good design file, 3D paving works great. I still think generally if we get the base done, and again, depends on the job. If it's a straight overlay, that's different. There is no opportunity, more than one opportunity for improving smoothness. But if we've got more than one opportunity, maybe 3D is the answer to use on the base material, and then 2D grade control when we get to the surface. Again, the screed's free floating. It's going to put its best, smoothest mat when it's free floating on the mix. And this picture just showing again 3D. I think some of the good applications really, well, when I say good, I guess I kind of mean no-brainers. When we get into some of these complex designs like racetracks or specialty projects, I'll call them, where you got a lot of spirals, twists, turns, super elevations, particularly new construction, great technology to help with smoothness. So, last thing I'm going to talk about here is e-routes. So this is a Caterpillar offering on monitoring the paving process. Again, we're not the only one that has this. A lot of the other manufacturers have similar technologies, and there's some independent ones out there as well. But just to highlight what it is here, so we're tracking truck location, loadout data, and all that, and it's also including electronic ticketing. So big thing here: truck timing, trucking reports, production tonnage. Got the mobile alert and the data storage component. So this just gives kind of an overview. So on the right-hand side of the screen there, you've got what we call a geofence around the plant site. So basically it knows, it's tracking when trucks enter and exit that plant site. There's also ticketing, electronic ticketing information. So once that ticket gets printed, it's printed electronically and captured by the system. So the truck leaves the plant, so we've got monitoring between the plant site, and then when we get close to the job site, there's a couple geofences. So basically the truck is on the job site, and then a smaller geofence right around the paver itself, indicating that that's where we assume at that point that when the truck is within a certain distance of the paver itself, that truck is unloaded or it's mixed into the paver. Different user interfaces. So on the left side is just what I'll call the web-based or the PC version of all the data. On the right-hand side, you see the mobile app version. So the mobile app is what typically the foreman or anybody on the job site is going to use. And again, I'm not going to get into any depth on this. I just wanted to give a high-level view of it. But they can track how many tons of mix are at the plant, how many tons of mix are on site, how many are tons are in transit, and track that down to each individual truck. It can look at each truck's ticket and see all the information that would be on a paper ticket today. So whether it's the running total on tonnage, the mix type, the load out time, load out temperature, if that's measured at the plant. So there's tons and tons of info there. Look at it and say, hey, my next truck's going to be here in 3 minutes, or my next truck's not going to be here for 45 minutes. So it helps me as a paving foreman or on the road make decisions. Do I stop the paver? Do I build a new transverse joint? Do I reduce my paving speed? What do I do? So there's lots of options, but all the data is there. This is the electronic ticketing component. So showing the desktop version here, but again, you can do it on the mobile app, the same thing. Go in, tickets, there's your ticket printout. So again, that ticket is going to be whatever is on a paper ticket today. So whatever that plant is printing on that ticket goes on this electronic ticket. And again, it's, tap it, you can email one ticket off. At the end of the day, you can create a report, email the whole day's production off. Just a lot of things you can do with that data. Cycle times, all that. Again, not going to get into the nitty-gritty here, but one thing that's kind of nice, gives you a quick visual. So if you look at that real quick, to me, I just look at that and go, hey, my cycle time just went up a lot, and it looks like most of it is waiting and loading at the plant. So maybe that's time I need to call the plant. Maybe they've throwing other customers in there and delaying my trucks, and it's causing me grief in terms of continuous paving and smoothness on my job. Lots and lots of data. And how do we look at that data? We can bring it all together in beta. So the Paver-Mounted thermal profiling data, we can bring that into beta. And also bring, of course, intelligent compaction data into beta. And beta, again, is really the analysis tool that brings all the manufacturer's data together. So you as an owner agency don't have to have Voglo's software or Caterpillar software. That data all comes into beta and can be analyzed. And some technology and training things. Again, lots of stuff out there. I'm just showing what we have, but all the manufacturers have some good training material out there, different apps for helping plan production and monitor continuous paving operation. Well, that's all I have right now. And again, I don't know exactly how we're doing the question and answer today, but there's my email, my phone number. If you're high tech, that QR code should scan on your phone or your scanner, and that's got all my contact information in there, and I'd be happy to answer any questions at any time. So with that, I will pass things over to Henry here. Are you there, Henry?
All right. Yeah.
Yes.
Hey,
all right.
Thanks a lot. It was a great presentation. A lot of great points. The features and the techniques that you talked about were were spot on. I think mostly used on, I think, just about every manufacturer across the market. So I'm not going to spend any time or too much time going over those again. But I did want to just bring to the table one item or one feature that we offer, we at BoMag offer, to help solve this segregation, material segregation, thermal segregation. We have our remix system, anti-segregation system. So what we have in the hopper, we have 4 conveyors, or excuse me, not conveyors, but screws, if you will. So the augers, you have a pair on the left, you have a pair on the right. They interlock and they move the material back to the screed, moves the material evenly. And it reblends 100% of the mix in the hopper. And most importantly, it reblends that mix right before it hits the screed face. So it really goes a long way to in helping eliminate that thermal segregation and that material segregation. Want to also point out that it pulls the head of material, or excuse me, it pulls the hopper material evenly. In the early days when we first started taking a look at this technology, we figured out that with just an auger with the same pitch, it pulled the asphalt pile to the rear against the bulkhead of the machine, and it created segregation. And that was easily to recognize in the beginning. So what we did, and what you'll see on these remix augers, is they're actually pitched differently. There's a 10-inch pitch, 11-inch pitch, and a 12-inch pitch. And I'm talking about the distance between the ribbons, if you will, the flights. So what you'll see in the hopper itself, the material drops straight down. So you're not moving that hopper material around and creating more segregation, or at least not creating as much anyway. So moving that material straight down in a nice fluid motion, reblending it right before it gets to the face of the screed goes a long way, with lots of data to back up the benefit of this system. Also, I'd like to point out that Todd, you talked about the centerline segregation, something that we as manufacturers you're constantly, trying to eliminate, and you're fighting it. There's things that can happen. Deflector plates can get bent. There's always been a problem with that dead zone in the center of the screed. Another nice feature of this remix system is there is no center gearbox. So there's no center line segregation. There's nothing there. There's no void to fill. So the gearboxes, if you will, or the chain boxes, are on the outboard sides where normally you would see the bearing or the hangers bearing supporting the spreading augers. So that helps a lot with eliminating that segregation. Yeah, but these augers, they have to be maintained. We'll tell you that, during your wintertime maintenance, take some time to hard face these augers. You want to keep them serviceable, and they'll go a long way. And there's within that spec, or within that thermal spec, we've seen. I won't quote the numbers or what the Celsius or temperature variances are, but there's penalties, but there's also bonuses. So as long as if you can keep that machine in that bonus, then you're making money on top of money. So it goes a long way. So the thermal image there on the bottom, is a typical image of what we see. It works extremely well. Yeah, I didn't bring a bunch of slides, but because I knew Todd would hit on the vitals, but at least I wanted to talk about one additional technology that we at BoMag bring to the table. So I guess with that said, Todd, thanks for your presentation and thanks for your time, and I guess we'll move on.
All right, thanks, Henry. Yeah, no, that's great technology. Very good. Thank you for bringing that. And with that, I will hand it off to Nars.
Okay, I guess I'm on next. This is Nars with Wirtgen America. Welcome to our webinar and good morning. So Todd and I discuss the possibility of talking about our technology and also trying not to do too much overlap. So I'll focus a bit on the principles of the free-floating screed and some of the reasons why we developed these technologies. So I'm having a little bit technical difficulty here. All right, I think I got it now. Okay, so these are some of the things I plan on covering. We'll look at the paving process, the principle of the free-floating screed. That's usually drive our technology. We'll look at machine controls, past and present. Technologies we have that enhances smoothness, some of the features that enhance consistency, and a bit on 3D paving. Then we will look at technology that we have to minimize and manage segregation. So placement-related pavement failures. We'll look at remixing at placement, why and where. And then we will look at Paver-Mounted thermal profiler and some different material management system. So going back to the basics, we all know the free-floating screed, the mat behind the screed is not held to depth by any mechanical or hydraulic device. It's held to grade with 5 forces in balance or 5 forces in equilibrium. So the secret to consistent mat depth is really consistency. So all the features we design in our equipment is how do we manage each of these 5 forces to maintain consistency. Of course, the weight of the screed is usually constant, that does not change. But we have the force exerted by the tractor, which is a pull force. We need to give the operators the ability to maintain that consistency. We need to give the operator design features to maintain material head consistency. When it comes to the reaction force and the frictional force, that is usually in the mix design. So if we change the mix design at placement, usually by segregating it, then we can change the R and F force. So what are all the technology that we use to manage these things? So changes in the pull force, the material head force, the reaction force, the frictional force, those could all impact smoothness. But changes in R and F would also impact density, which we all know impact the life of the pavement. So pass controls, you can see on the left side, that's usually about the time I joined this business, that's what the controls look like. Today, you could see what we refer to as intelligent machine controls. So intelligent machine controls, of course, was facilitated by the Canvas system. That technology started with the introduction of the Tier 3 engine emission control. So we needed some sort of a computer on board to manage the engine. Now that we have that, what else can we use it for to enhance the paving process? So that's what really led the way for intelligent construction technology. On the left, you see the smart or intelligent tractor control. On the right, you see intelligent screed control. So what are some of the features that we have to enhance smoothness? Today's design allows the operators to pick his paving speed using his speed dial based on his trucking, his rolling capability, his plant production. He can select his paving speed, dial it in before he starts paving. For whatever reason, should he stop, he pulls the lever back to neutral, the screed goes into a hydraulic lock so it does not settle in the asphalt. That's automatically being done. Operators don't have to pay attention to do that. Once he takes off, usually when you stop, we have material cold in front of the screed. That will change the R and F force, and usually the screed would rise to give you a hump. So if we lock the screed once we stop for about 4 seconds or 18 inches, once after we take off, then we will prevent that hump. So we lock it to prevent the settling, and we lock it to prevent the hump, and then allow it to go back into flow. Some other technology that we've introduced recently is one of the biggest challenges for operators, especially in super elevated turns, is to hold a nice smooth radius. Usually you jog into it, and as we know, we rock the screed back and forth, we disturb the 5 forces in equilibrium, and we end up with a rough ride. So we give the operator the ability to trim his steering into that. So he can use these buttons, even making a left turn, he hit that left button a couple of times until he picks his radius. The machine will hold that radius until My system is playing games on me. Okay, we're back. So the operator has the ability to hold a nice smooth radius. Once he gets out of that radius, then he hits that yellow button and the paver goes back to straight steering again. So not only we maximize smoothness with these features, we also provide for a better joint. The straighter you steer, the better joint you could create. What else we use technology for to help operators manage consistency? Today's most paver design have independent auger and conveyor control, so we can precisely manage that head of material. Also, there are times that you have failure in sensors and cables. We give the operator backup controls in this control screen that he can turn his automatics off, but then he can set whatever RPM he needs based on his project and his material delivery. So again, we can manage consistency. In terms of eliminating human interface, 3D is one technology that could allow that. But as Todd says, 3D have its place. Usually if you can build your base, you can build your binder with 3D, and then you do with your averaging ski or any automation system, that's usually the way to go. But to do paving, you need three things really. You need a 3D job file. You need 3D positioning instruments, which could be the Topcon, Laikram, or Trimble, some of the most popular brands. And of course, you need machine control. So with our Nivlatronic 3D option, we allow Topcon, Trimble, or Leica to communicate directly with our machine controls, thereby eliminating extra cables and control boxes. So our business is machine control. The professionals in 3D positioning is usually Topcon, Trimble, and Leica, and then whoever surveying company creating a 3D file. So take those three together, you could pave in 3D. So 3D files usually could be in two forms. If it's a new project, a new highway, a new airport, sometimes these days you see new parking lots being done. So you would have a design file already made. You can take that design file, use your 3D positioning instruments to drive the machine. Or in the case of an existing road, you can use a Topcon Smooth Ride system or the Trimble Precision Paving system. You can scan a surface and build a 3D model to feed back into the paver. The advantage here is if you have a low spot, as you can see here, as you build the 3D model, you can put some more asphalt in that area to allow for that extra compaction. So in these kinds of technology, we see the possibility to eliminate some of the cases where we do leveling course, or what some refer to as scratch course. You can build a model off the base, feed that back into the paver, and in our case, use our sensors and our control systems together with the Topcon or Trimble positioning systems to manage. We also have the ability to control all three dimensions of the pavement. We could control the screed depth, left and right. We can control the screed width automatically with the 3D file, and we can also steer the paver using the 3D file. This technology has been around for a while, but it has not been embraced totally yet by the asphalt. Cold material, roller compacted concrete, cemetery at the base on new projects. That's where we see this technology being. So those are some of the features that we have to enhance smoothness. Come back to maintaining consistency in the R and F force. As I mentioned earlier, the R and F force is driven by the mix design, the gradation, the asphalt content, the temperature of the mix, and whatever fillers we have in there. So if the plant's doing its job, the only way we can change R and F at placement or during hauling is if we segregate the material. So our objective in the next couple of slides is, what are the features, what are the technology we have to really manage R and F? So first, let's define segregation. Todd picked on this at the start of his presentation. I'll try to go in a little bit more detail. Gradation segregation, usually mostly visible, occurs during handling. It is where the large stones separate from the smaller stones and the fines. You create a slope face, you allow the larger stones to roll until they hit the object, and then it stops, leaving the fines behind. But as we know, the heat and asphalt is in the fines. So when we have gradation segregation, not only are we separating the larger stones from the fines, we're also separating the asphalt and the heat. Then we have thermal segregation. Thermal segregation could be created by gradation segregation, because if we separate the fines where the heat is, then of course, wherever there is gradation segregation, there will be thermal segregation. Again, that will be visual. We could also have thermal segregation from cold material, whether we sit too long at one spot, the mixed cold in the auger chamber, or we leave a large amount of material in the hopper insert and sat for a long period of time. That material will cold also. We can also have plant issues. So pure thermal segregation mostly are not quite visible. There are times, if depending on how cold it is, it will drag behind the screed, so you can see some difference in the surface texture of the pavement. But generally, thermal segregation usually not visible. As you can see here, these are all clearly gradation segregation, no fines, so definitely will be thermal segregation. Over here, as you can see, it's pretty difficult to see any form of segregation. So how does segregation impact the screed? Let's take a look at the screed from the side. There's your thickness control screws. That's a strike off. The strike off usually strike the amount of material flowing under the screed. The trailing edge of the screed plate sets your mat depth. So from the strike off point to the trailing edge of the screed plate is usually your vibratory screed compaction. So what's happened in that process? From the time the strike off strikes the material off, as the screed moves forward, the larger aggregate moves around to close the air void. So the larger aggregate, of course, as it moves under the screed plate, we have a small frictional force. But your compaction force, which is your R force, is compacting the material from that point to that point. What is happening in that process is the fines act as roller bearings for the larger aggregate. The asphalt acts as a lubricant to allow the larger aggregates to move. So at any point, if we change the consistency of the material significantly, then the behavior of the screed changes. So what happens in that process? Usually at the end of load, the next load comes in, start of load, or if we're paving with a material transfer, we run the insert low. We could have 1 ton to 2 tons of segregated material flowing under it. So the behavior of the screed performance will change because we don't have as much fines and asphalt lubricant prior to that segregated material. So the more than likely what will happen is, as the segregated material flow under the screed, we change the internal frictional resistance of the material, and that will force the screed to seek a new grade. So under situations like these, more than likely we'll have a rough ride, not because of thermal segregation, but because of gradation segregation. Thermal segregation just happens to be there because the fines were lacking. Management could also manage smoothness. If we minimize the impact of these types of segregation, then of course we maximize our smoothness. So why do we use material transfer? We use material transfer for non-contact continuous paving, exchange truck without stopping or bumping the paver to break those 5 forces in it. We also use it to maximize smoothness. If we don't stop, the screed don't settle, we don't get a hump. But we also use material transfer to provide adequate surge so we can exchange trucks without running the material low and ending up with segregated material. So the material transfer also used to reblend your end of load and start of load segregation or any other form of segregation that we have to deal with during the handling. So let's look at the handling process. Ignoring the plan for now, just look from the time the truck is loaded to the time the material is delivered to the screed, which is our last point of handling. Remember, segregation will only happen when you handle the material. So there's 5 locations of handling, excluding the plant for now. We load the truck at the plant. The truck drives to the job site. If a material is prone to segregation, you will find all the larger stones rolled to the sidewall of the truck. So that's the first form of segregation we have to remix. The second form of segregation is, as we mentioned earlier, your end of load and start of load segregation. The third form of segregation we have to remix is cross from hauling. Cold material, truck bed may not be tarred properly, so we need to remix those, assuming, of course, that the plant is doing its job. So these are all before the material transfer. Now, unfortunately, I don't have any slide in here showing windrow elevators, but Todd did mention some of that in his presentation. After the material transfer is the last 2 points of handling. And that is, as the material transfer fills the insert and as the tractor is delivering the material to the screed. So most tend to ignore these last two because everyone felt like if you have a material transfer in the job, all the problems are resolved. No, it's not. We need to focus on these 5 areas of remix. Don't have time to cover it all today, so we'll just mention briefly 2 of the 5, which is the last 2. Todd did a good job covering most of it. I'll go back into some detail. So let's look at hopper insert design. Hopper insert is usually one of the culprits for segregation under the bearing hanger. Todd had a nice slide there where he showed with a thermal profile segregation under the auger box, but right outside of that, under the bearing hanger, was also 2 continuous streaks. Those streaks come from any material that rolls to the sidewall, rolls on the side of the slope of the pile in the insert, hits the sidewall, and follows the sidewall to the edge of the conveyor chain, which is almost in line with the bearing hanger. So these baffles, if the insert is filled only in the middle, reduce the length of that slope face and cut back on the amount of material that hits the sidewall that ends up under the bearing hanger. The baffles allow the material to flow straight into the flight chain and minimize the chance of material rolling to the sidewall of the insert. Whatever rolls to the front and the rear wall gets remixed as the flight chain pulls the material to the auger. So a couple of other features is the bottom of the insert is tapered. So this is your engine cowling. This is where the material transfer is. If you look closely, the front opening is wider and also sits right where the flight chain starts to rotate. So there's no dead spot for the material to sit and build up in this area here. The rear portion of the insert opening is narrower, a difference of 8 inches. So any large stones rolling along the sidewall here naturally spreads over an 8-inch width to minimize any concentration of segregated stone. Also, by not having any overlap here, prevents material from building up because generally that area is used for your volume. So if that material sits there for a long period of time, it gets cold, and of course that could provide some significant thermal segregation. So those are some of the features. Don't cost much. It's all passive remixing, but significantly help to provide material consistency. Then it comes to the last point of handling, which again, Todd did a pretty good job explaining those in detail, so I will not go through in details, but you can look at this in 3 categories. We need hardware, material chutes, auger, reverse augers, tunnel extensions, auger extensions, all of which Todd covers. But we also need proper setup of your auger and conveyor sensors to ensure that the auger and conveyors are turning consistently, your auger height is positioned relative to your mat. And then of course, we need all the proper adjustments. So to manage the material as a tractor is delivering it to the screed, we need to look at it in 3 forms: hardware, setup, and adjustment, which Todd did a pretty good job. So summarizing some typical failure due to segregation: longitudinal streak, again, that's under the auger box, that's about in the bearing hanger. In this case, definitely came from the sidewall of the hopper insert. And here you can see some tearing and dragging of cold material. So gradation segregation, usually the streaks are not enough to impact the ride of the pavement. And it's created after the material transfer. No material transfer will minimize these type of segregation. Yes, we can make some minor adjustments with lead crown, auger height, and we can cover that with fines. But if you're using a thermal camera, you will pick up a temperature differential here because the larger stones at the bottom are cooler and you will see a thermal differential at that. Second form, most that we see mostly is open texture, open voids, which is usually from your end of load or end of insert. It's gradation segregation, so of course it will be thermal segregation there also. That could be created before or after the material transfer, depending on what we're doing. That will definitely impact smoothness. So Paver technology can now identify these blemishes. Just referring back to some information that has been floating in our industry over the last couple of years, what are some of the impacts of segregation? Previous studies have indicated premature failure with a temperature differential of greater than 25 degrees. So the question is that because of thermal segregation created by gradation segregation, or just thermal segregation without gradation segregation? Our focus always seems to be focusing only on thermal segregation. Now, this is a topic by itself. We don't have time to cover this today, but I hope at some point in the future we will be able to have some more discussion on segregation. But irrespective, whether it's gradation or thermal segregation, temperature is a common factor. And we can use temperature to monitor thermal or gradation segregation. By the way, courtesy to Washington State DOT and Texas DOT for these slides. So how do we manage and monitor temperature? Now I can only focus on our technology here. I'd focus some on the CAT technology. There's other stuff out there I'll mention here in a minute. So these are some of the technology that we have to manage segregation and consistency. Remember, we're not only managing segregation, we need to manage material consistency as we deliver it. So there's three modules. We can look at the data collection module, which is, in our case, Wirtgen, which is a Paver-Mounted thermal. This is a data management. WITAS Paving Daku is our analysis. So we could use VEDA, as I will mention later, to analyze the data from our thermal camera. We can also use our WITAS Paving to perform analysis on trucking management. And I'll go through the details on how WITAS Paving Daku work here in a second. We also have a much more sophisticated system called WITAS. We'll not spend much time on that today, just a few slides on that. So Wirtgen, which is our Paver-Mounted thermal profiler, it's integrated into the Paver control and is displayed on the tractor operators. There's several other systems out there. Todd talked about the CAT Trimble system. MOBA been out with their system much longer than everybody else. And of course, now we have TopCon out with their system too. So everybody now pretty much have a Paver-Mounted thermal profiler system. So just focusing on our Wirtgen for now. So we have the thermal camera mounted on the paver at the back. Right next to it, we can have a weather station so we can document all the ambient conditions together with the thermal profile. We also have a thermometer mounted at the back of the front bumper of the paver, so we can also measure the ground temperature. So we have the ground temperature, we have the ambient conditions, and we have the thermal profile. All of which displayed on the tractor control. So in a nutshell, those are all the typical components we have that is tied to our Wirtgen system. So the data from Wirtgen goes into our portal and export to VEDA. So from our system, we export that data directly to VEDA. Then, of course, VEDA users will grab that information from their download box and use the VEDA software to perform all their analysis. So users are responsible to learn VEDA. That's a must. Must learn to use all the appropriate filters to remove skis, safety edges, those typical objects that create problems for us on the thermal profile. We have to be careful not to lose valuable data when we're filtering these. Some choose to reposition their camera to avoid reading the ski. Bad practice. We don't need to do that. You need to learn to use the filter. And here is compliments of Dr. George Chang. We could see here averaging ski and a couple of other devices impacting the thermal profile. Of course, all of those things you need to learn how to filter. So that's Paver-Mounted Thermal Profiler. What else can we do? Our WITAS Paving DACU is a material management system. So you can have the road scan, which is an optional camera, tied also to the WITAS Paving DACU system. It's got its own analysis and report. And if it's thermal camera related, we use VEDA. The rest of it is being done with Wirtgen WITAS Paving. So it uses a smartphone or a tablet to communicate directly with the paver. So how does all of that work? Let's take a look. So the paver built, the paver has a TCU built into it that generates a Wi-Fi within 150 to 150 foot radius. The TCU communicates directly to a Wirtgen server through a cell communication, and the TCU communicates to the smart device through Wi-Fi on the job site within 150 to 250 foot. So the foreman or the supervisor enters in the morning the length of the job, the paving width. We also have an optional screed width sensor so you can monitor all day long how wide you're paving. He also entered the planned tonnage and density, start time, finish time. So all of that information is entered up front, what job it is, the job order number, and all that good stuff. And then he could use his smartphone to monitor. He would see the project name, the time paved, the operator, of course, I'll go to later what he used this blue strip, this green strip for. And of course, during the day, he can monitor his tonnage, his distance, and his density. At the end of the day, he hit complete order. I'll come back to that. So the paver creates a barcode. With a smartphone or a smart tablet, you scan that barcode. Those smart device now becomes part of the system, communicating directly with the TCU built into the paver. The truck ticket will have a barcode also printed on it with all the truck information. So once the smartphone scans the paver barcode, then the smartphone will now be able to scan the barcode on the ticket. So the minute the barcode is scanned, that information instantly popped in front of the tractor operator on the tractor control screen. So the operator sees how many trucks is in front of him, how many load is in each truck. The operator also would visually be able to see how long he's been paving, the distance he's covered, the tonnage he's covered, and he'll have a barcode here that shows, give him a range where he is at with his density. So the number of trucks, tonnage in front of the paver, time paved versus planned time, distance paved versus planned distance, tonnage laid versus planned time. At any one point, if he's running a thermal camera, he can switch his screen back over to see what his thermal profile is. So at the end of the day's paving, the foreman hits finish, and of course, the report is automatically emailed to everyone that is chosen to be on that list. If a thermal camera is included in the system, he will also have a thermal profile. So not to go into details, there is a report that instantly gets emailed to you with the location on map where that project is, your tonnage and all that good stuff here. It also shows your truck efficiency. Also shows, in this case, this is our thermal profile, not from VEDA, but you will see the same results from VEDA. Shows how long you stop, when you stop, and it will give you a complete view of your trucking efficiency. So what does that do for the foreman? It provides to him electronic documentation, makes his life easier during the day. So electronic documentation of the ticket, you don't have to carry a roller anymore to measure his distance. It's all done with the paver. His yield is already done with a paver. His material is also being managed. And of course, all the information will be provided to him and anyone else at the end of the day. So that's a WITAS Paving DACU and or Paver-Mounted Thermal Profiler system, all designed to manage consistency and using temperature to manage the R and F force. Now, we could also take it to another level. We can take the thermal profile and we can, through Wi-Fi, send it to a tablet into the roller cab, so the roller gets to see what the thermal profile is. And lastly, our WITAS Paving Plus, I'm not going to spend much time on this. This is a huge module. It's all for material management, equipment management, all of the above. But two of the things that is unique to our market here is, of course, e-ticketing. So this module have an e-ticketing module within it. And we also have a module that could monitor the truck through GPS from the plant to the paver, however we choose to. Some of these features we're kind of holding back to see what direction the U.S. market is going. With that, I will end and turn it over to anyone for questioning. I'm not sure how we will do the question. Any ideas?
Yeah, I'm not sure that our attendees are able to unmute themselves, but they can certainly send questions through the chat box. And you can send those questions, I believe, to everybody, or there should be a Q&A. Looks like we do have some questions here.
For some reason, Lori,
Okay.
for some reason I got kicked out. Can you read the questions? Can it?
It looks like Todd was able to answer the question.
Okay.
And it was from a while back, so I can't remember if that was maybe at the beginning of your presentation or at the other one.
Yeah, I think that question was on folding the hopper wings. What mix sizes should you and should you not fold the hopper wings? So generally, I go with the recommendation: any mix size larger, 3/4 inch or larger max aggregate size. Generally, it's better not to fold the hopper wings on the paver for segregation.
Todd, a question from you. Were you able to see my presentation? It looks like I got kicked out.
Yes, we could see it the whole time.
Yeah, yeah.
I can't see anything anymore. All right, then if there's any questions for me, somebody could read it.
Okay, I do have a question from Ben Worrell. He's asking, how many years does it take for a paver operator to take to effectively learn all they need to know? What training is required?
Todd, you answer that.
You never stop learning, right? But I mean, I would, if you've got somebody with you, training you, all that, I mean, I would at least a couple of years before you half proficient. Hopefully that answers the question. But I mean, yeah, there's obviously a lot of nuances to the whole process. I mean, one of the biggest things, not to go off on a tangent, but is, again, it all goes back to the trucking, which was why a lot of this technology is so good, and continuous paving. So where we run into a lot of problems is paver stops, and then when we do stop is managing, and NARRA's covered it as well, is managing that head of material. And so that's our conveyors and our feed system on the paver. So yeah, it can take a while to really get comfortable with that stuff.
Okay, and then we do have a question from Tim Kowalski in the Q&A box here. Will there be a document to identify segregation from the thermal imaging to help out customers?
Yeah, I mean, that's something we as a group have started working on. Great question. And yeah, so I'd like to, a little bit I've got going, but I know others have. So we're going to try and pull all that together and share it with the industry. So yeah, great question. So one thing there, can you hear me?
Yep,
Lauren?
we can hear you.
I want to make sure. I see one question asking about real-time smoothness. So another great question. So one of the, everybody knows smoothness is a big thing when it comes to paving and quality. And one thing to date we've not been able to do is measure smoothness during paving. So right behind the screed as we're paving along, we've got all these indicators of how we're doing and those sorts of things. So one thing that we have proposed as an industry, not just Caterpillar or myself, is research on finding a tool that will measure real-time smoothness behind the paver. So we're kind of hoping that that'll move forward and maybe have some more things to share in a year or two's time on getting something implemented in that area. And I think that would really complement some of the thermal data and other things that we're getting. It's just would be one more piece of information to correlate to operational practices and equipment setup.
So Lauren, I've got a text here from Jeff Benfield from Alabama. Wants to know if these presentations will be archived somewhere for one to access.
Yes, I have been recording this session, and all of our other future sessions will be recorded, and I will be posting them onto our YouTube channel and posting links, to each individual presentation or webinar on the Pavement Workshop webpage. So it usually takes me about a week to kind of get everything edited down and posted and all of that stuff. And yeah, someone's asking for the PDFs. We can certainly post PDFs of the presentations.
I think one question too, Lauren, is PDHs, professional development.
PDHs, yes. I think that's up to. We aren't providing anything, so but you can we'll have the recording if you want to, if you need to be able to show something that you attended.
Yeah, 2 minutes to go.
I received one more question. Are companies working on new screed technologies, vives, tamping, or other that may help in these areas of density or smoothness?
Can you read that again, please?
Sure. Are companies working on new screed technologies in parentheses, vibes, tamping, other, that may help in these areas of density and smoothness?
Okay, so I'll answer that. We have technologies that's been available for a long time now that could develop up to 100% density. And these compacting devices not only provide density, but it also needs the material to minimize some of these segregation, but not eliminate it. So screed technology already available based on that question, but no technology will eliminate severe thermal segregation from end of load and start of load segregation of any significant amount.
Yeah, I think generally speaking, as manufacturers, I mean, we're always looking at improving our products, so screeds included. But I think the NARS maybe know better than I do. I think the main two screed types out there are tamper bar and vibratory screeds.
Yeah.
So.
Well, compaction, high compaction and vibratory screed. There's tamper bars, and there's also tamper bars and pressure bars, where the pressure bars is similar to a tamper bar, but it's at the back of the screed plate and is driven by a hydraulic spike. So the frequency is much higher than a tamper bar, which is mechanical.
Mm-hmm.
All right, and then I do have one other question here in the Q&A section from Tim Kowalski again. Do you guys feel that operators understand how screed, lock, freeze, and hold work, and what activates each?
I'm not sure everyone will understand, but I could explain. I did try in the presentation to explain when the FNR lever is pulled into neutral, some equipment allows the screed hold or lock. What that is, it prevents the screed from settling into the asphalt. Some designs,
I'm sorry to interrupt you. I think his question is if you feel that the operators understand that process.
uh,
I think some do, some don't.
some don't.
Sure.
Again, it's come back to training. It comes back to training.
Yeah.
Yeah, if I may, I just worked with an operator this week that did not know what his screed assist function was. He saw the switch on his dash panel. We provide the operator with the option of using it or not, and it's even adjustable how much lift it gives during a stop. So I could see the light bulb go off in his head. Oh yeah, that's why I'm getting that sinking mark every time I stop my paver. So yes, sir, you have to turn that on. That's a feature that we give you, and to help eliminate that settling.
I would say, just taking a guess on the training that I do, I would say maybe 20% of the operators, at least that I've worked with in training, actually know about that feature. And again, maybe maybe we need to make it more obvious on our particular model. But and
I think I'm going to jab at the manufacturers here. We all call it a different name, so we didn't help with the confusion. We created.
Yeah. Yeah. And then I'll add that if you're going to use your screed assist, or if you have the ability to turn it on or off, you need to leave it on or you need to leave it off, in my opinion. If you start switching, you turning it on and off in the middle of a job, you're changing the gradation of that screed or that lifting force of that screed. So that was one piece of advice that I also offered. Just my personal opinion: turn it on in the morning when you start paving, and leave it on unless you're transporting the paver. In that point we advise turning it off, so there's no additional load shock or anything on the screed hydraulic system.
Well, very good. I'm not trying to take over as moderator here, but I guess I know our time's up. Are there any more questions coming in, or?
We still have 56 on board, so.
Yeah, there's one here that I'm getting here. It says, what is your opinion of real-time thickness measurement? I wonder, what Todd or anybody else, what is real-time?
I can take a stab at that. We have sonic technology where we can measure the depth of the mat at the back of the screed. We can use that same technology to measure the base in front of the screed, and we can do a differential between the two sensors to give you your mat depth. So that technology is available. It's just not have been packaged correctly.
Yeah.
And I said yet.
All right. Well, maybe I'll
Maybe it.
take the initiative not to cut anybody off, but if there are no more questions, I would like to say.
Oh, George is just saying good job.
Oh, I'd just like to say thank you, everyone, for attending today, and I'm sure speak on behalf of Nars and Henry as well. Great questions.
Yeah.
And thanks.
Hey Todd, I got one comment from Jeff from Alabama.
Yeah.
Please tell the group that Alabama appreciates the knowledge you have all shared. Now we need to push this info out to our contractors and inspectors.
There you go.
Well, Jeff, I would say that's a group effort, and we all need to work towards that.
Yeah. That's how I make my living, doing that as best as I can.
And thank you, Lauren, for hosting and getting us all set up here.
Absolutely. This was my first time around using this platform, so I've learned a couple things along the way here, but I'm glad it seemed to work smoothly and we didn't have any major issues, so that's great.
Yep, I thought it worked really well. Thanks a lot, Lauren.
All right, everyone, thanks.
Great.
Thank
Thanks,
you.
everyone.
Signing out.
Be safe out there.